Alright teens, we're going to talk about FRQ number 2 from the BC 2014 exam. What we're going to do first is we have a polar graph. So this is the question really quickly. I have the answer key in front of me, but I'm not going to reveal that to you. We're going to do it together. Alright, so we have this polar curve, and the first thing I'm going to do is I'm going to pull out my calculator. Alright, this is why I'm not filming from my phone, is so I can pull this out. I want to make sure that I have this in polar mode. And I'm going to go ahead and put some functions there. So r equals 3, and r equals 3 minus 2 sine 2 theta. Alright. If I go to my graph, I see approximately the shape I'm looking at if we're looking at the first and second quadrant. Alright, so question part A is let R be the shaded region inside R equals 3, inside R equals 3 and inside R equals 3 minus 2 sine theta. Find the area of R. So, first things first, A. R equals. We have a full quarter circle in the second quadrant with a radius of 3. So we have pi 3 squared, and then we're dividing that by 4. Sorry, I just got a Snapchat. Now in quadrant 1, it's just the area bounded by the second curve. So we're going to go ahead and use our 1/2 0 pi over 2 of 3 minus 2 sine 2 theta squared d theta. Because it's 1/2 r squared d theta, remember. Once we're there, you can say we have 9 pi over 4 plus something. Do we know how to do that? Probably technically. Should we spend our time doing that on a calculator problem? No. So I'm going to go back to my screen here. Go to Math 9. We're going to integrate from 0 to pi over 2 of, I can go ahead and go to my variables, go to my y variables, my function. Oh, not what I want. I want to go to my variables. I want to be in the correct place, so when I plug that variable in, I'm struggling with my calculator right now. Pardon me, kids. We want to go to polar. And it's R2 because we already had it defined. D theta. Wait, don't forget to square it. Square it. Wait, Mr. Woodruff, you forgot to do a thing. I need to divide this by 2 because I have a 1/2 there. Plus 9 pi over 4. We are going to get 9.708 when we round that. Cool. We're being asked for the area. It doesn't give us any any units or anything, so let's go ahead and grade this per AP. So we have 1 point for the integrand. Sorry, I'm looking at my screen and trying to write. 1 point for the limits, so recognizing where this is happening, and then 1 point for the total area, for 3 points total. Alright, for B, we are finding the value of dx d theta. Let me go back to this. So dx d theta at theta equals pi over 6 for r equals 3 minus 2 sine 2 theta. Okay, so x equals r cosine theta. This comes from our understanding of trig and translating back and forth between polar and rectangular functions. So I can go ahead and say I have 3 minus 2 sine 2 theta times cosine of theta. Now, if I want to take the derivative on each side and then divide by d theta, so dx d theta, this is going to be a product rule problem. We're going to end up with we can compute this out, or let me see. If this works. If it doesn't, I will edit it out. And pi over 6. Cool. So I just know that I have this expression at pi over 6 equals theta. We get negative 2.366 as our answer. All right, for C, we're asked to find the distance between the two curves. Changes for 0 to theta to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. So the distance is represented by the outer curve minus the inner curve. So our outer curve in this case is the circle, and our inner curve in this case is that curvy thing for 0 to pi over 2. So from there, we can represent that as 3 minus (3 minus 2 sine 2 theta). Alright, when we simplify that out, that becomes 2 sine 2 theta. And we're looking for the d theta when theta is pi over 3. So that is something we can plug in, or we can just take the chain rule, which would be 4 cosine 2 pi over 3. Is that true? Yeah. Which is going to be 4 times negative 1/2, or negative 2. You could also be at this point where you find the derivative, or find this and then take the derivative like I did on the calculator here, if my phone screen didn't just die. So you can do the same process. It depends on what your comfortability is and where you are with your time. I have the time to, I'm not crunched for time, and I think about these better logically like this. All right, for part D, where are we at in recording? Cool. For part D, the particle is moving along the curve so that it's drawn out using R2, and that d theta dt equals 3 for all time greater than or equal to 0. That's just a for all symbol for fancy mathematicians. What we're looking for is dr dt at theta equals pi over 6. So this is our question. First thing we need is some way to relate all of these. So I want to think about dr dt and how I can get that from the thetas. If I think about what I'm going to get from this r here, I'm going to get dr d theta. And then to essentially cancel this out, d theta dt is where that'll come in. So we can go ahead and plug these things in. I know that we're looking at pi over 6. So I have dr d theta is going to equal negative, nope, positive 4, negative 4 cosine 2 theta. My apologies, I can't deal with negatives right now. And we can plug that in here. So at pi over 6, it's negative 4 cosine 2 pi over 6 times 3, which is equal to negative 4. You can't see what I'm writing. Cool. Negative 4. Cosine of pi over 3 is going to be 1/2, so it's 1/2 times 3, or we get negative 6. Now, I'm realizing I forgot to go through the AP points of the other problems, so I'm going to go back and do that for you real quick. For B, when we're expressing x, that's a point. You need to express x in terms of thetas, and then you have an answer point. For C, you need to express the distance in some way. As long as you're figuring out that you're showing the difference, you're chilling. All right, and you get 1 point for the answer. And for D, we're talking about chain rule here. So 1 point for looking at the chain rule, and 1 point for your answer, which is negative 6. Cool. Thanks, guys.